Okay, here's a problem I'd like you to spend a bit thinking about. Press pause while you think about it. Well, what we notice is that since this is 150 degrees, this right here is 30 degrees. So let's take this triangle here and redraw it. So I'm going to take this side here, I'm going to extend it out in this direction. And so now this angle of 30 degrees is here. The right angle is here, although that's a horrible line segment right there, but who cares? So this is our 30-degree angle. This is our 90-degree angle. This side here is root 3. This is 1. This is our 60-degree angle. And this is the hypotenuse of 2. So this 30 angle here, this 30-degree angle here is exactly the same as this 30-degree angle here. So I know that I can go a distance here of square root of 3. Okay, so I go square root of 3 in this direction. Since I'm going to the left of the y-axis, that tells me that my x-coordinate is negative. So the x-coordinate here is negative square root of 3. Then to get up to this point, I have to go up 1 unit in the y direction. Okay, so up means positive y, so this y-coordinate is positive 1. Okay, so here at my angle of 150 degrees, a point on the terminal side of that has x-coordinate negative 3 and y-coordinate 1. And those, again, I found just by taking a look at the 30, 60, 90 right triangle. Okay, why don't you guys work on these examples here? Okay, so use this right triangle here to find x and y in each case. Okay, for the first one, it's probably helpful to redraw the triangle so that it looks more like the angle that we're looking at right here. So here we have it. This x is this length here, and that is length 1. So it says we go out 1 unit there, and then we go up a distance of y. And that distance that we need to go is square root of 3. So this length here is square root of 3. So it means x, since we're in the positive side, x is equal to 1, and y is square root of 3. Okay, for this one here, we have a 30-degree angle here, because we went around 330 degrees, which means we're just 30 degrees shy of 360, which would be fully around, or I should say all the way around, which means this distance here is this distance here, which is square root of 3. So x is square root of 3. This distance here is this 1 here, but since y is below the x-axis, y is negative. Okay, so this is a distance of 1, but the y-coordinate itself is negative 1. Okay, let's put those examples to use by evaluating sine of 210 degrees. So the first thing that we need to do is we need to find a point on the terminal side of 210 degrees. Let me start by drawing that angle. Okay, now we need to find a point on the terminal side of that angle. What we observe is that from here to here, it's 180 degrees. So to get to 210, we have to go 30 more degrees. So this angle here is 30 degrees. Okay, using this triangle here, I can now put values for x and y. Okay, this value of x here is negative square root of 3. And this value of y is negative 1. So now all we need to do is we need to say, okay, sine of 210 degrees is y divided by r. The one thing that we're missing is this value of r. But that value of r is just the length of this hypotenuse. So r is equal to 2. Okay, so if we were to find it the other way using the square root of x squared plus y squared, we find that it's the square of negative root 3, which is 3, plus the square of negative 1, which is 1, so that's the square root of 4, which is 2. Okay, so sine of 210 degrees is the y-coordinate divided by r, so that's equal to negative 1 divided by 2. So sine of 210 degrees is negative 1/2. Okay, work on these three examples here. Press pause while you work on them. Okay, remember in each case you should draw the angle, in the last case it's in radians, and then find a point on the terminal side. Okay, in the first case we can just use the point that we just found. So x is negative root 3, y is negative 1, and r is 2. Cosine of 210 degrees is the x-coordinate divided by the value of r. So cosine of 210 degrees is negative square root of 3 divided by 2. Okay, in the second case, 270 degrees is this angle here, and a point on the terminal side of that angle is 0, negative 2. So r is the square root of x squared plus y squared, so r is 2. Cosine of 270 degrees is the x-coordinate divided by r, and so that's 0. Okay, here, just because you haven't been working with radians for that long, let's first convert to degrees by multiplying by 180 over pi. Okay, if you simplify, you find that 5 pi over 4 radians is 225 degrees. So let's draw that angle. Okay, now we have to find a point on the terminal side here. Since this is 45 degrees, I know that this is the line y equals x, and so the x and the y coordinate are the same everywhere along this terminal side. So let's say use the point negative 3, negative 3. Then we have to find r, using the fact that r is equal to the square root of x squared plus y squared. We find that r is equal to 3 square root of 2. Now sine of 5 pi over 4 radians is equal to the y-coordinate of this point divided by r, so it's equal to negative 1 divided by the square root of 2.